So Henry St. John's wort originally comes from China. It comes from the Yunnan province in the southwest of the country. And it is believed it may have been introduced to South Africa as an ornamental, but there's no evidence as to how or why it got into the country. In 2006, KZN Wildlife noticed that this plant was invading areas in their reserves, and after an extensive study by their students, they found that it's invasive in the KwaZulu-Natal Midlands and the Drakensberg. It has been spotted in the Eastern Cape, but no surveys have been done there, so we can't really say anything about that yet. It's found to invade watercourses and undisturbed veld going up the slopes of the mountains, so it's quite widespread. Because it is widely established, we need to ask if Baker's rule is being applied to this species. And Baker's rule states that plant species that are capable of self-pollination are more likely to colonize an area than species that are self-incompatible or that are dioecious. So in order to test this, I did pollinator exclusion experiments. And how I did this was, we had 4 treatments. I had the bagged treatment, which is at the top there. That excluded pollinators for a week. And that sounds like a very short period of time, but this plant can go from bud to fruit in less than a week. So 1 week of bagging. I took the bags off because my initial study found that if you leave the bags on for more than a week, it kills the fruit and you get nothing, you get dead material. So for 1 week, the plants were bagged, and that was to prevent pollinators coming in and to hope that the plant would self-pollinate in that time. I then also had emasculated flowers, which is the bottom picture. And how I did this was I opened a bud and I pulled off all the anthers to prevent any self-pollen being deposited on the stigma. I then also had a hand-pollinated treatment where I took pollen from a plant a bit of a distance away and put that on the stigma. And then we had a control, which was just any other flower that was untreated on the plant. I then counted the seeds under a microscope, and it looks like a weird smattering of stuff. These seeds were tiny. That's weird. Okay, so we had 2 different kinds of seeds. We've got our potentially viable seeds, which are the darker ones. And then these hundreds and hundreds of aborted seeds. And I had 25 grid blocks, which I counted for each sample. And they were in the region of 1,000 to 2,000 seeds per pod that came out of each flower. So the results, as you can see, the number of aborted seeds was much, much higher than the potentially viable seeds across all treatments. If we look just at the number of viable seeds now between treatments, so the control and the hand-pollinated treatments, there was no significant difference between the 2, and there was no significant difference between emasculated flowers and between self-pollinated flowers. But there was significant difference between those 2 groups and those 2 groups. If we look at the differences between the different sites that I used 3 sites. Mbona is a private game reserve in the Midlands, and Giant's Castle and Monk's Cowl up in the Drakensberg. And the only site where there was, only treatment where there was significant difference between sites was the self-pollination. And Giant's Castle was significantly higher than Mbona and Monk's Cowl. So what does all of this mean? The low